कि आज हमने करना है चैप्टर 12 ऑपरेशन रिसर्च का। चैप्टर 12 है, फर्स्ट है प्रोजेक्ट मैनेजमेंट। प्रोजेक्ट मैनेजमेंट होता क्या है? प्रोजेक्ट मैनेजमेंट का मतलब है हमने ऐसे नेटवर्क्स बनाने हैं, ऐसा शेड्यूल बनाना है, ठीक है, ऐसी प्लानिंग करनी है कि हमारा जो वर्क है वो रैंडमली चलता रहे, यानी कि रुके ना बीच में का। ठीक है, ऐसी टेक्निक्स फॉलो करनी है जिससे हमारा वर्क जो है वो कंट्रोल्ड रहे और प्रॉपरली चलता रहे, बीच में स्टॉप ना आए किसी भी कारण से। ठीक है, इस तरह से उसको गाइडलाइन करनी है। फॉर एग्जाम्पल, कपड़ा मान लो स्टिचिंग के लिए है, ठीक है, स्टिचिंग टेलर है मान लो, उसने अपने प्रोजेक्ट को मैनेज करना है, तो वो कैसे करेगा? सबसे पहले एक कटिंग के लिए रखेगा, देन एक स्टिचिंग के लिए रखेगा, देन एक पैकेजिंग के लिए रखेगा। तो वो प्रॉपर इसी प्रोसेस से जाएगा सारे कपड़े। ऐसे नहीं है वो सबसे पहले स्टिचिंग के पास चला जाएगा बिना कटिंग। तो मतलब कि जब हम एक प्रोजेक्ट को प्रॉपर प्रोसेस के साथ लेके जाते हैं, देन उसको बोलते हैं कि प्रोजेक्ट को मैनेज किया गया है। इसकी दो टेक्निक्स हैं प्रोजेक्ट को मैनेज करने की। फर्स्ट है PERT, सेकेंड है CPM। ठीक है, PERT टेक्निक्स क्या है? एलिमेंट ऑफ अनसर्टेनली इन द एस्टिमेशन ऑफ द ड्यूरेशन, वन एस्टिमेट ऑफ कंप्लीशन टाइम ऑफ ईच एक्टिविटी। PERT में क्या होता है? हमें तीन तरह की कोस्ट दी होती है, ठीक है, या कह लो कि हमें तीन तरह की कोस्ट निकालनी होती है, ठीक है, जिसमें एक ऑप्टिमम कोस्ट होती है, ठीक है, इस तरह से हमें टोटल तीन कोस्ट निकालनी होती है। लेकिन CPM में हमें सिर्फ एक ही एस्टिमेशन, यानी कि एक ही चीज को ध्यान में रख के निकालना होता है, सिर्फ एक ही तरह की कोस्ट निकालनी होती है, फ्री फ्लो निकालना होता है। ये सर्टेनिटी के साथ होती है एक्टिविटी, ये एक्सपेक्टेड कंप्लीशन ऑफ टाइम फॉर ईच एक्टिविटी। हर एक्टिविटी के लिए एक टाइम जो है वो सेट किया जाता है कि इतनी टाइम में के लिए ये एक्टिविटी होगी, देन उसको सेकंड के लिए भेज दिया जाएगा, देन उसको थर्ड के लिए भेज दिया जाएगा। ठीक है, लेकिन ये जो है ये कुछ एक ड्यूरेशन फिक्स की जाती है कि उस ड्यूरेशन के अंदर अंदर ये काम हो जाना चाहिए। इसकी एक्टिविटी बेस्ड होती है, ये एक पूरी एक्टिविटी वन सिंगल एक्टिविटी के रूप में किया जाता है। ठीक है, देन नेटवर्क कंपोनेंट्स आ गए। नेटवर्क कंपोनेंट्स क्या है? नोड्स। नोड्स क्या होते हैं? नोड्स आर ब्रेक पॉइंट रिप्रेजेंट एंड्स ऑफ एन एक्टिविटी स्टार्टेड टू अनदर वन। ये जो बीच में आप लाइन देख रहे हो दैट इज नोड। ये जो उसने कनेक्ट किया है दूसरे को दैट इज नोड, ये वाला, ये नोड है। ठीक है, एक्टिविटी ऑन एरो। नोड आर कनेक्टेड बाय एरो। जब नोड, यानी कि नोड क्या बोलते हैं, जिसको हम रस्सी बोल देते हैं सिंगल लैंग्वेज में, तो ये एक तरह की रस्सी है। ठीक है, नोड जब एरो के रूप में कनेक्ट कर रही है दूसरे को, तो उसको बोलेंगे एक्टिविटी ऑन एरो। एरो के ऊपर एक्टिविटी 2 है। ठीक है, लाइक दिस, यानी कि सारी एक्टिविटी जिस तरफ जा रहा है एरो, तो सारी एक्टिविटी कहाँ पे रिप्रेजेंट कर रही है? यहाँ पे। ठीक है, ये यहाँ पे सब आ रही हैं, सेंट्रलाइज हो रही हैं एक जगह पे, ये डिसेंट्रलाइज हो रही है, यानी कि एक जगह से बाकी जगह पे जा रही हैं एक्टिविटीज। ठीक है, और एक्टिविटी ऑन नोड्स इसमें क्या है कि विदाउट डमी, सीधा ए एक्टिविटी से बी एक्टिविटी पे चले गए। लेकिन इसमें क्या है? इसमें डमीज यूज किए जाते हैं। ठीक है, इसमें डमी यूज नहीं होते हैं। देन इसके टाइप्स आ गए। ठीक है, एरर्स एंड डमीज, यानी कि जो मिस्टेक्स और डमीज बनाते हैं उस वो क्या होती है? लाइक दिस। ठीक है, दैट इज लूपिंग। देन डैंगलिंग, लाइक एक एक्टिविटी के अंदर कोई और एक्टिविटी, दो एक्टिविटी के साथ एक एक्टिविटी कनेक्ट होना, एक एक्टिविटी के अंदर एक एक्टिविटी। पैरेलल, यानी कि सब बराबर चल रहे हैं। सब पैरेलल चल रहे हैं, बीच में इन्होंने डमियां लगा दी हैं, ठीक है। ए जो है वो बी से भी होके जा रहा है, ए जो है वो सी से होके भी जा रहा है। देन हम सीपीएम और पर्ट करेंगे। सबसे पहले हम पर्ट करेंगे, ठीक है। हाँ जी, जहाँ पे
New
समझ में नहीं
techniques.
आएगा, जहाँ पे समझ में नहीं आएगा वहां पे बता देना, ठीक है।
So we have already discussed about critical path method in a separate video. In that video, we have discussed how to construct the CPM network, determine the critical path and project completion time and computation of total floats and free floats for non-critical activities.
ठीक है, हम इसमें क्रिटिकल पाथ मेथड पढ़ेंगे।
All these things we have discussed in detail in that particular video. So now we are going to see PERT. Okay, so there is a small difference between CPM and PERT. So in CPM, for each and every activity's timings are deterministic in nature. That is, for each and every activity, only a single duration will be given. With that, we have to proceed everything. But whereas in PERT, each activity will have three time estimates. The three time estimates are, the first one is optimistic time, second time is most likely time, and the third one is pessimistic time. So with this we need to proceed everything. So this is the basic difference between CPM and
ठीक है, सीपीएम में एक सिंगल टाइम ही डिसाइड होता है, उस टाइम के अंदर अंदर एक्टिविटी करनी होती है। पर्ट में 3 तरह का टाइम आपको दिया होता है, ऑप्टिमिस्टिक टाइम, मोस्ट लाइकली टाइम और पेसिमेटिव टाइम।
PERT. So now we are going to discuss PERT along with one problem. Look at the problem. Consider the following table summarizing the details of a project. So here we have 10 activities A to J and predecessors also given for each and every activities. Okay, then duration. I told you no, for each and every activity three time estimates are given. So first one is optimistic time for the each and every activities, and second one is most likely times, and the third one is pessimistic times. So these are the three time estimates are given for each and every activities separately. With this information, they ask you to construct the project network, and second one, find the expected duration and variance of each activity, and third one, find the critical path and expected project completion time, and the last one, what is the probability of completing the project on or
ठीक है, ये 4 चीजें हमने इसमें निकालनी है। फर्स्ट की प्रोजेक्ट का नेटवर्क क्या होगा, देन उसका एक्सपेक्टेड ड्यूरेशन एंड वेरिएबल टाइम क्या होगा ईच एक्टिविटी का, देन क्रिटिकल पाथ क्या होगा उसका, उस पूरे काम को कंप्लीट करने के लिए, यानी कि कौन से नेटवर्क से वो निकल के जाएगी, देन प्रोबेबिलिटी ऑफ कंप्लीटिंग द प्रोजेक्ट बिफोर 22 वीक्स, 22 वीक से पहले पहले कितना प्रोजेक्ट डन हो जाएगा ये भी बताना।
before 22 weeks. These are the things we need to find with the help of this information. Okay, so now first we are going to see how to construct the project network. See, in order to construct the project network, we need to have two important information.
I knew I was underwater.
हाँ जी, जब भी हमें
Is activity and second one is predecessors. Okay, here we have 10 activities A, B, C, D, E, F, G, H, I, J, and predecessors are For A, B, C, there is no predecessor, and for D, A is there no. So where A is completed, there you can start activity D. Okay, at the same time you have to check whether the particular activity is a predecessor for any other activity. See, D is there no. So D is the predecessor for activity I. Okay, in the same way, look at the next activity, activity E. So activity E starts where B is completed. At the same time, check E is the predecessor for any other activity. Yes, E is there. So E is the predecessor for activity H. At the same time, E ends along with F. Both E and F together completed in one particular node. Okay, look at the next activity. So activity F starts where activity C is ended. At the same time, F ended along with the other activity, that is along with E. So activity F starts where C ended and activity F ended along with E. Next activity is G. So G starts where activity C is ended.
ये समझ में आ रहा है? वो ये यहाँ पे एक्टिविटी लिखी है, यहाँ पे प्रेडिसर्स लिखे हैं। एक्टिविटी का मतलब है जब वो स्टार्ट हुई और प्रेडिसर का मतलब है कि जब वो एक्टिविटी खत्म हुई। फर्स्ट ए बी सी जब स्टार्ट हुई देन इनका कोई भी एंडिंग पॉइंट अभी हमें नहीं दिया हुआ है, तो हम स्टार्ट कहाँ करेंगे? डी से। डी कब स्टार्ट हुई? जब ए एंड हुई, यहाँ पे आ गया। ठीक है, ए बी सी का एंड पॉइंट यहाँ पे आ गया, यानी कि डी इज द एंड पॉइंट ऑफ ए। ए जब एंड हुई तो स्टार्ट क्या हुआ? डी। डी के स्टार्ट होते ही ए एंड हो गई, ई के स्टार्ट होते ही बी एंड हो गई। और अब बी कब एंड हुई है? बी के एंड होने से पहले कौन सी एक्टिविटी स्टार्ट हुई है? एच स्टार्ट हुई। ठीक है, ये स्टार्टिंग है और ये एंडिंग है।
At the same time, G is a predecessor for activity J. Here, G and H together completed in one particular node. The next activity is H. So activity H starts where E and F is ended. Okay. At the same time, H is the predecessor for activity J. But here, H and G together ends in a same node. The next activity is I. I starts where activity D is ended. Okay, the last one is J. So J is the activity which starts where H and G ended. So this is the relationship between different activities and predecessors. So with this you can start construct the project network. Now we are going to see how to construct the project network. So look at the problem. For activity A, B and C, there is no predecessor. Okay. So straight away you can start with A, B, C. For each and every activity, we need to have two nodes. First one is starting node and another one is ending node. Okay, so this one is starting node and this one is ending node. For activity A, we need to have two nodes, starting node and ending node. At the same time, for activity B also, this is the starting node and here we ends. Okay, activity B. Okay, at the same time, activity C. This one is starting node, this one is ending node for activity A. For activity B also, starting node, ending node. For activity C, starting node, ending node. So without any predecessors, these are the three activities straight away starts. Now let us see the problem. Look at the next activity. Activity D starts where activity A is ended. See, activity A is ended here. Now you have to start activity D from here. Node number 5, activity D. The next activity is E. So activity E starts where activity B is ended. See, activity B ended here. Now you have to start activity E from here. Next activity, activity F. So activity F starts where activity C is ended. At the same time, F ended along with the other activity, that is along with E. Activity F starts from here and ends along with E. The next activity is G. So activity G starts where activity C is ended. C ended here. From here you have to start next activity, that is G. The next activity is H. So H starts where E and F ended. At the same time, H ends along with G. See, here E and F ended together here. Now you have to start the next activity. The next activity is H. H starts from here and ended along with G. The next activity is I. I starts where activity D is ended. Activity D ended here. From here you have to start I. The last activity is J. So activity J starts where activity H and G is ended. So activity G and H ended here. You have to start from here, and this is the last activity, no. So ended with the last node, that is our last node is 8. With this information, we have constructed the project network. Let us see the next calculation. The next one is find the expected duration and variance of each activity. Okay, look at the problem. Here we have 10 activities. For each and every activities, there are 3 expected times are given. The first one is optimistic time. The next one is most likely time. And the last one is pessimistic time. Okay, with this information, we need to find expected duration and variance. Expected duration means it's just like a mean duration, that is average. Then we have to find the variance. In order to calculate the expected duration and variance, we need to use some formulas. Calculation of the expected duration and variance of each activity. Here 10 activities are given and 3 estimated times also given. Optimistic, most likely and pessimistic. So with this we need to find mean duration. Mean means expected duration. Mean duration, and the next one is variance. Okay, so in order to calculate mean duration, that is average, we need to use one formula. For mean, that is TE. TE stands for expected duration. Expected duration means mean duration. TE is equal to optimistic time plus 4 times of most likely time plus pessimistic time divided by average, that is 6. Optimistic time, pessimistic time and 4 times of most likely time. Total together 6. So with this formula you can find the average, that is expected duration, that is mean duration. So this is the formula to calculate the expected duration for each and every activity. For the first activity A, 5 plus 6 into 4 plus 7 divided by 6. For activity A, 5 plus 4 times of 6 plus 7 divided by 6. 5 plus 6 into 4, 24. So 5 plus 24 plus 7 divided by 6 is equal to 6. At the same time for B, for activity B, 1 plus 4 into 3 plus 5 divided by 6. 1 plus 4 into 3 plus 5 divided by 6 is equal to 1 plus 12 plus 5 divided by 6. Answer is 3. In the same way, we need to find the mean duration for each and every activity. For activity A, the mean duration is 6. For activity B, mean duration is 3. For activity C, 1 plus 4 into 4 plus 7 divided by 6 is equal to 4. For activity D, 1 plus 4 into 2, 8 plus 3 divided by 6, 2. For activity E, 1 plus 4 into 2, 8 plus 9 divided by 6, 3. For F, 1.
This free masterclass is exclusively for all data analysts, business analysts, or any other analyst out there. The most obvious next career move for you is to become a data scientist. By attending this masterclass, you will gain a step-by-step career guide on how to prepare to transition into a data scientist role at the world's top tech companies. Click on the link below to register.
ऑप्टिकेयर फ्रॉम मैट्रिक्स। क्या आप जानते हैं ऑप्टिकेयर को 1 लाख से भी ज्यादा प्रोफेशनल हेयर स्टाइलिस्ट यूज करते हैं। ये आपके बालों को रखे सलोन स्मूथ। ऑप्टिकेयर है हेयर
1 plus 4 into 5, 20 plus 9 divided by 6, 5. For G, 2 plus 4 into 2, 8 plus 8 divided by 6, 3. For activity H, 4 plus 4 into 4, 16 plus 10 divided by 6, 5. Then activity I, 2 plus 4 into 5, 20 plus 8 divided by 6, 5. For J, 2 plus 4 into 2, 8 plus 8 divided by 6, 3. In this way, you can find mean duration. The next one is variance. For variance also, there is a formula. The formula for variance is square of standard deviation. That is pessimistic time minus optimistic time divided by 6 whole square. This is the formula to find out variance for each and every activity. That is pessimistic time minus optimistic time divided by 6 whole square. For activity A, pessimistic time is 7, optimistic time is 5. So 7 minus 5 divided by 6 whole square. 7 minus 5, 2. 2 by 6 whole square. Answer is 2 divided by 6 just whole square. Answer 0.11. The variance for the first activity is 0.11. 0.11. For the second activity, pessimistic time is 5 minus optimistic time is 1. So 5 minus 1, 4 divided by 6 whole square. For activity B, pessimistic time is 5 minus optimistic time is 1 divided by 6 whole square. 4 by 6 whole square. 4 divided by 6, 0.666 whole square. 0.44, 0.44, 0.44. In the same way, we need to find variance for each and every activity separately. For activity C, 7 minus 1 divided by 6 whole square. Answer 1. For activity D, 3 minus 1 divided by 6 whole square, 0.11. For activity E, 9 minus 1 divided by 6 whole square, 1.78. For activity F, 9 minus 1 divided by 6 whole square, 1.78. Then activity G, 8 minus 2 divided by 6 whole square, 1. For activity H, 10 minus 4 divided by 6 whole square, 1. For activity I, 8 minus 2 divided by 6 whole square, again 1. For the last activity, 8 minus 2 divided by 6 whole square, again 1. So with this formula, we have calculated variance for each and every activity. Look at the problem. So far we have done the first one, construct the project network, and second one, find the expected duration and variance of each activity. Now we are going to see find the critical path and expected project completion time. See, in order to find the critical path and expected project completion time, we need to have duration for each and every activity. So in this problem, we have three estimated times now: optimistic, most likely and pessimistic time. Here we need to take the mean duration, that is expected duration for each and every activity that we have calculated in the previous calculation. See, mean duration, that is expected duration for each and every activity. Now you have to note down all these duration in the project network. For activity A, duration is 6 weeks. For activity B, 3. For activity C, 4. For activity D, 2. For activity E, 3. For F, 5. For G, 3. For H, 5. For I, 5. For J, 3. For A, 6. For B, 3 weeks. For C, 4 weeks. For D, 2 weeks. For E, 3 weeks. For F, 5 weeks. For G, 3 weeks. For H, 5 weeks. For I, 5 weeks. For J, 3 weeks. After entering the expected duration for each and every activities, the next step is we need to find critical path. In order to find out the critical path, it has two phases. Phase 1 is determine earliest start time of all the nodes. So this is called as forward pass. The second step is determine latest completion time of various nodes. This is called as backward pass. These are the important steps need to be followed in order to find out the critical path. Let me show the calculation for earliest start time and latest completion time for each and every nodes. For each and every node, we need to find earliest start time and latest completion time. So here we have two squares now. The lower square denotes earliest start time. The upper square denotes latest completion time. So we need to find earliest start time and latest completion time for each and every node separately. In order to find out the earliest start time for each and every node, there is a formula. Okay, we have to use the formula to find out the earliest start time for each and every node. For the first activity, that is for the first node, the earliest start time should be 0. You have to start with 0. Let me explain the formula to calculate earliest start time for other nodes. So this is the formula to find out the earliest start time. That is earliest start time is equal to maximum of earliest start time of ith node plus duration for the particular activity. Okay, so when we have two options to move on from one node to another node, we have to take the maximum value. So let me explain this formula along with the problem. See, for the first node, earliest start time is 0. Okay, so now we have to find the earliest start time for node 2. So the previous node starting time is 0. 0 plus duration of this particular activity is 6. So 0 plus 6 is equal to 6. Okay, node 2 is over. Now see the node 3. For node 3, the previous node is 1. So earliest start time of node 1 is 0. 0 plus 3, 3. So earliest start time for node 3 is 3. For node 4 also, the previous node is 1. So earliest start time of node 1 is 0. So 0 plus 4, 4. So earliest start time for node 4 is 4. 0 plus 4 is equal to 4. Okay, now see the fifth node. For node 5, the previous node is 2. So earliest start time for node 2 is 6. So 6 plus 2, 8. Next, node 6. See, when we see node 6, here we have two options. That is, the node 6 starts after completing third node and after completing fourth node. So here we have two options. So we need to take the maximum value. Okay, for this one, for node 3, the starting time is 3. So 3 plus 3 is equal to 6. Whereas For node 4, the starting time is 4. So 4 plus 5, 9. So which one is maximum? 3 plus 3 is equal to 6, but 4 plus 5 is equal to 9. So this one is the maximum value. For forward pass, we need to take the maximum value. So 4 plus 5 is equal to 9. So earliest start time for node 6 is
50 lakhs per annum.
What? 50 lakhs? That's your salary right now?
Yes.
What do?
I'm an AI tools and chat GPT expert.
Okay, so what degree did you do to master this?
I didn't need any fancy degrees or spend lakhs of rupees on expensive courses to learn this skill.
So then how did you master these AI tools and get such a high salary?
I started by attending B10X's certified AI tools and chat GPT workshop. In just 3 hours, I was equipped with all the required knowledge that I needed to enter this field.
Okay, and
After the workshop, which was just for rupees 9 by the way, I started getting a call from a lot of recruiters, and I finally landed my dream job with a top MNC at a salary package of 50 lakhs per annum.
wow, that's impressive. So what if somebody wants
is 9. Then node 7. For node 7 also, here we have two options, that is from 4 to 7 and from 6 to 7. Again you have to find the maximum value. So look at this. For node 4, the earliest start time is 4. So 4 plus 3 is equal to 7, or 9 plus 5 is equal to 14. So which one is maximum? 9 plus 5 is equal to 14. 14 is the maximum value when compared to this calculation. So take 14 as earliest start time for node 7. Then the last one is 8. For 8, again we have two options. The first option is 5 to 8. The second option 7 to 8. So again you have to find the maximum value. For 5 to 8, the earliest start time is 8 plus 5 is equal to 13, or 14 plus 3 is equal to 17. So which one is maximum? 17 is the maximum. So we have to take 17 as earliest start time of node 8. After completing the earliest start time of each and every nodes, now we need to find the latest completion time for each and every node. So the latest completion time is otherwise called as backward pass. For backward pass, we have to start from the last node. Okay, for the earliest starting time, we have started with the first node, but when we calculate the latest completion time, we have to start from the last node, and you have to take the same value as latest completion time for the last node. See, for the last node, the latest completion time is same, 17. Okay, now we have to apply the formula to find out the latest completion time for each and every node separately. So this is the formula to find out the latest completion time. That is, latest completion time of ith node is equal to minimum of latest completion time of jth node minus duration of I and j activity. So now let me explain this formula along with the problem. See, the latest completion time for the last node is 17. So now we have to calculate the latest completion time for the previous node. The previous node is 7. Okay, so 17 minus 3. 17 minus 3 is equal to 14. The next node is 6. For 6, the previous latest completion time is 14. 14 minus 5 is equal to 9. Okay, the next node is 5. For 5, just see the previous one. The last node is 17. 17 minus 5 is equal to 12. Next one is node 4. See, for node 4, we have two options. Okay, that is from 7 to 4 or from 6 to 4. So here we have two options. No. So in that case, we need to take the minimum value. Okay, so see the first one. 14 minus 3 is equal to 11. Whereas, see this one, 9 minus 5 is equal to 4. So which one is least value? This one is the least value. That is 9 minus 5 is equal to 4 is the least value when compared to this one. So take 4 as latest completion time for node 4. The next one is node 3. For node 3, we have only one option, that is 6 to 3. So the latest completion time for node 6 is 9. So 9 minus 3 is equal to 6. Latest completion time for node 3 is 6. The next one, 2. For node 2, the latest completion time for the next one is 12. So 12 minus 2 is equal to 10. Node 2 is over. Now see node 1. For node 1, here we have 3 options, that is 2 to 1, 3 to 1 and 4 to 1. So here we need to find the minimum value. So see the first option. The latest completion time of node 2 is 10. So 10 minus 6 is equal to 4. Second option is node 3. For node 3, the latest completion time is 6. So 6 minus 3 is equal to 3. Okay, the next option is 4 to 1. For node 4, the latest completion time is 4. So 4 minus 4 is equal to 0. So which one is minimum value? 0 is the minimum value when compared to this one and this one. So now we have to take this value. That is 4 minus 4 is equal to 0. So we have got the earliest start time and latest completion time for each and every node separately. Now we can find out the critical path. Critical path is the longest path in the network. So in order to find out the critical path, we need to check 3 conditions. Okay, the first condition is the earliest starting time of the starting node must be equal to latest completion time of the same starting node. Okay, both earliest start time must be equal to latest completion time of each and every.
ये 3 कंडीशंस है, अगर ये 3 कंडीशंस फुलफिल होंगी तभी हम मानेंगे कि ये सीपीएम का मॉडल है.
Every starting node. This is the first condition for critical path. And the second one is earliest starting time of ending node must be equal to latest completion time of ending node. The third one is 7 to 8. So this is the critical path, that is 1 to 4, 4